Hey, welcome. This is Benjamin. Welcome back for a new year of virtual IoT. Happy New Year to everyone. We're really happy to be back. We already have a few sessions scheduled over the next few weeks, and starting today is going to be a presentation by two gentlemen from Bosch Software Innovations, by Kai and Michael. We are going to talk about Eclipse hawkBit. So some of you might know about Eclipse hawkBit, some of you might not. There is a lot going on in this Eclipse open source project. It's all about software updates for IoT devices. So without further ado, I think Kai Zimmerman, you're first. You're up next. So why don't you briefly introduce yourself and get started with your presentation for all the attendees probably watching us on YouTube. There's a chat. This is how you can ask questions. So feel free to chat among yourselves or to just also ask questions. You can also use Twitter and the virtual IoT hashtag. So without further ado, Kai.
Yeah, thanks, Benjamin. Actually, 2 words about myself before I'm going to get started. So my name is Kai Zimmerman. I'm, as Benjamin already mentioned, from Bosch Software Innovations, and I'm project lead for Eclipse hawkBit. And in addition, over here at Bosch, I'm also product owner for Bosch IoT Rollouts, which is actually a product that is based on hawkBit. So I think Michael will introduce himself when his part will come. So we will start with a couple of slides, some background, what we did, some updates on the current roadmap and about 2017 and what we did in the recent months since our last webinar. And then Michael will join with a demo in part 2. So Eclipse hawkBit. And again, I repeat what Benjamin also already said. Feel free to ask questions. I think Benjamin will, in this case, interrupt us, and we will try to answer them as we go. Eclipse hawkBit, that aims to be a domain-independent backend solution for rolling out software updates. So I think that sentence already says pretty well what we do. So hawkBit is a backend service. It's written in Java, completely open source, obviously. And the idea is to have a system that allows you to update software in IoT context. It offers basically everything you need, all the kind of functionality features to ship artifacts to IoT devices. And it offers a wider range of APIs and options of how to integrate them. Obviously, in IoT, not everything can be done through the same protocol. Sometimes devices define the protocol, the device management protocol on their own. Sometimes they are constrained, so HTTP might be too heavy for them, might need something smaller, like co-op-based, like that M2M, for instance. So hawkBit offers extension points in order to do so. That being said, though, concerning it's a backend, there are other open source projects. Actually, we have on our GitHub page 2 clients already linked. That for various kind of devices offer off-the-shelf integration with hawkBit. I'm pretty sure there are even more. That's just the 2 ones, the 2 projects that have been brought to our attention. So we link them from our site, but I'm pretty sure there are even more. And I will come later on through the talk through an array also of, well, we call them examples, but you might also call them clients for different kind of scenarios. The motivation historically has been that we figured out over here at Bosch in a wide array of IoT projects that basically every time you need software update, as soon as you connect the device, and might even only be for security reasons, you need the capability to update devices, and you have special kind of requirements, especially in IoT context. So updating an IoT device is not the same thing than updating, for instance, a server in a data center. Of course, historically, very often IoT solutions have done this on their own. And of course, there was a lot of duplicate work because you had to redo this for every new IoT solution and every new device you got connected. So we figured out over here, okay, it makes sense to have a standard system for software update. We also learned in a wide array of IoT projects that software update from a backend perspective is relatively domain independent. So updating a vehicle or a smart heater or even going down to a connected sensor, from a backend perspective, it's pretty much the same. At the end of the day, you need to bring files to a device. obviously on the device, things are completely different. Every device does a different thing when it comes to software update, and you have sometimes very simple devices, just having one firmware image. And you have also more complex devices. If you look at a vehicle, for instance, a vehicle is built out of dozens of devices, actually, that can be updated. And this has to be done in an atomic way or transactional way. There is, of course, historically, a lot of device managements on the market. These are systems that do a lot more than just software updates. So usually software update is in device management only a subcomponent. However, they bring a lot of complexity to the project. And that's why we decided years ago, okay, next to a generic device management that can take care of configuring devices, managing devices, it is a good thing to have a focused system just on software update. I will come to that on a later slide again. Yeah, what is hawkBit? So by the way, while I'm at this slide, I can't see it because this Google Hangout pop-up is below here. If you go on the slides, I think we have published the link. There are even additional links to our documentation and our GitHub repository. So if you have additional questions that you don't want to ask here, you can also, just check out our documentation, our GitHub repository, and there is a Jitter chat. The team is always live or online, and of course there's also on Eclipse the dev mailing list, so you can also ask questions offline or look into deeper in a more deeper way into the documentation. So that being said, that is hawkBit. This picture has been quite stable over time. If you look into the center, hawkBit offers 3 core capabilities. One is obviously it has a repository, so it knows about the devices, it knows about the software, and it knows what has been installed on the device in which point in time. So it does not only know what is currently installed, but also has a full history of what has been installed in the past, which is one of the requirements you see very often in IoT. For reliability reasons, for legal reasons, you better be able to know what was installed when on which device. Artifact content delivery, obviously. So hawkBit does this on its own. So it has its own API or streaming API, if you will, to stream artifacts through HTTP. But there is even the possibility to extend this capability. For instance, if you want to bring a content delivery network to the table, or you have your own shipment service, or you need to support additional products, protocols in addition to HTTP, for instance, core blockwise transfer. And then there's the third area, and that is, of course, the heart of the product or the project, and this is update management, or what we also call rollout management. This is in the industry very often called campaign management. I will come to that later. It's basically about not just updating one specific device, but if you have a very, very large number of devices. So let's say you have 500,000 devices, and you want to roll out the update to all of them, but obviously not all of them at the same time. Coming to the green boxes, these are the interfaces that hawkBit has. On the top level, we have management UI, management API. So I guess the name speaks for itself. That's basically API and UI that you can use in order to maintain the repository, execute updates, check the update status, etc., etc. I guess this would be part of Michael's demo as well. From the project perspective, we try to keep those two always feature equal. Means even if we use a lot in our demos the UI, you can do everything that we do in the UI, you can do through API as well, and the other way around. So it has turned out to be quite practical to have a UI off the shelf, and of course an API for people who want to integrate or embed hawkBit into an existing IoT backend solution. And you can even run combinations of those. So using the UI for the experts, and then maybe have a simplified access to the API. So one use case for that could be, for instance, you have a call center. And when a customer calls and saying something is broken with my device, and then the call center agent in his support portal just want to quickly check, okay, what is currently installed on the device? Is the device up to date? Has there been a problem? Then you just go through that with that requirement through the management API. I think more interesting, however, are the southern side or bottom side green boxes. So as I said before, we offer different ways of how you can integrate your devices. What we have learned over here is that it is a good thing, and that is what Direct Device Integration API does, to have a standard API where you just have a client that is compatible to that API, and you can directly connect your device to the hawkBit server. It's an HTTP-based API with JSON payload, plus, of course, artifact streaming, and this then can be used. It's based on a poll mechanism, so basically the device asks in certain timeframes, for instance, every 5 minutes, every 5 days, it asks hawkBit, okay, do you have something to do for me? Do I need to install something? And of course, that API is then also used to push back feedback, like, okay, I started downloading the artifact, I'm done with downloading, I'm now going over the bootstrap mechanism, I'm rebooting, etc. And then, of course, to complete the state machine at the end, the device is pushing back the final state, like, okay, it's installed or installed with an error. This is quite useful, and many projects use it. And this has even the benefit that, especially if you use Direct Device Integration API and Management UI in combination, basically you have a software update system without the need to write even one line of code in the backend. It's just the system, and you install it and you run it. However, I will come to a few constraints later on. But in many cases, as I said before, the world is not that easy. Your device maybe already have a cloud connectivity or it follows a certain standard. We have listed 2 here that support software update, or ADM with GOMO and FUMO objects, or Lightweight M2M with the firmware update object. These are, by the way, just examples we are not offering, so that's why they are gray. Obviously, the integration you have to do on your own, but there's a lot of flexibility there. And you might even have your custom protocol, or you have already a connectivity from the device that you defined as part of your IoT solution. And software update is just one part you push through that channel. So for that, we offer what we call Device Management Federation API. It's an AMQP 0.9 based API. So most people use RabbitMQ. So it's message-based. And basically, yeah, it works not, technically it works more like a push mechanism. So as soon as you trigger an update inside hawkBit, you're pushing out messages to your connectivity layer, to the device, and then this layer does whatever he has to do in order to inform the device about the software update. And obviously it works the other way around. So again, like in Direct Device Integration API, you just put the feedback back into hawkBit, like, okay, installation is done. All of these 4 green boxes can be used together or combinations. As I said, you might have a scenario where you use Device Management Federation API and only UI plus maybe a little bit of Management API, or you might even have different categories of devices. So you're combining in one hawkBit installation both DDI and DMF connected devices. This is basically the core of the product. Maybe 2 more quick details on what the system offers. So hawkBit has a fixed data module for software. So it has the concept of a distribution set. Inside, it can have an arbitrary number of what we call a software module. And every software module, again, can have an arbitrary number of artifacts. So it can be quite a large tree if that is necessary. Or in the most simple case, it's just one distribution set, one software module, and one file, which, of course, in many projects is the case. But as I said before, there are many examples where you need much more complex scenarios. You can even run on hawkBit App Store-like scenarios. I mean, it does not offer an App Store by itself, but you could even use that in such a scenario by means that every device has a different setup, maybe of applications installed on it. All of that is possible. That being said, though, it's still a strict module. That means, for instance, it does not support larger trees, nested trees, or it does not support any kind of requirements checking or configuration management. So basically, at the end of the day, hawkBit will just do what you tell the system to do. So if you come up with a setup of modules that are actually not supported by the device, hawkBit doesn't care, which is go. This is something you have to take care of on your own in the system that feeds hawkBit with the software setup. I mentioned campaign management, or what we call rollout management. As I said before, this is basically about managing or having control over very, very large software update scenarios. Very, very large, from my experience, means already everything that goes beyond 1,000. So I guess Michael will show in his demo. You can quite easily, directly in the UI, by hand, if you will, update just one device or 5 devices. You can do this through API, but very, very fast stuff will get complicated and easy to keep under control. And for that, we created Rollout Management. So I guess Michael maybe will show something about that in his demo. As it's briefly described here, you basically take a group of devices, you identify them by rules that are defined inside hawkBit. So they are based on information that hawkBit has about the device. For instance, you could put some metadata on the device, like hardware vision or even locale, or in which region the device is. And then based on that, you can define rules in the kind of a notion like, for instance, okay, first update all the test devices, then update my local region, and then update the rest of the world, something like that. This has been done for various reasons. Obviously, it's a lot about load and control. Means you don't want to, press the big red button and ship maybe a gigabyte of data to 500,000 devices at the same time. You might have some trouble in your data center. But of course, even more important is the control part. So that means, as you can see here on the left side, it has a notion of what we call emergency shutdown. So you could, for instance, define, okay, if more than 5 devices have a problem, then the rollout would just shut down and will wait until an operator could check what happened on the device. This is kind of a safety net. That the idea was that it makes sure, that you don't push the big red button and then accidentally you break not just a small number of devices, but you break all of your devices, which could be, of course, kind of threatening in most IoT scenarios. Coming to that, this was basically a brief overview. I think you will get a much better understanding when Michael comes to his demo. As a project lead, I can't help it to talk a little bit about status and roadmap. So in 2016, the project was started, or I think end of 2015. So obviously, we had to do a lot about Eclipse IP process, et cetera, et cetera. So you need to know that historically, this was not an initial contribution where we started from scratch. What Bosch basically did is we open sourced an existing commercial product. So obviously that code base was not really originally meant to be an open source project. So there was a lot of stuff we had to do. And this was a big topic in 2016. And of course, a lot of project fundamental work had to be created, documentation, homepage. We provided a sandbox, which is actually linked here and also linked down here. Stuff like that to get going. And last year, we, in addition, provided or introduced the notion of having extensions. These are extensions that are managed by the project. We are not going to release them, but we will maintain them. So it's not just a loose list of stuff somebody did somewhere. Of course, it's an open source project, so everybody can do that. But as part of the project, we are hosting a small set of extensions on our own. Extensions where the committers make sure that they are maintained and stay compatible. Then another topic, and now I come to what I mentioned at the beginning, that historically, when we started, we were here a group of Java developers, and hawkBit in the beginning was more designed not really like a ready-to-go production-ready server, but more basically a framework. Means a lot of Java components that then people could use in order to create their own device management or software update system. We had a runtime example, but we always called it example. So we promoted that one. So hawkBit is now offering a runtime. It's a Docker image. However, I mean, if you want to go really, really IoT, means millions of devices, obviously there's a lot of stuff you have to do still in order to optimize it, embed it into your own cloud infrastructure, et cetera, et cetera. You might have the need to integrate it in your own security infrastructure for identity and auth, et cetera, et cetera. There's still stuff that needs to be done, but it is an off-the-shelf runtime. And I think for many people, it's working already off the shelf without any further ado. We did a lot of refactorings last year. Again, this has a lot to do with the history. So hawkBit was not as flexible as we wanted it to be. So we invested a lot into introducing additional API layers inside the code base, make it a lot more modular. so that you have a much easier time in case you intend to contribute to the project, or in case you want to create your own product on top of it. Yeah, I mentioned already that we even now have an image on Docker Hub, and we worked a lot, and this was primarily driven here by us from Bosch on performance topics. So as I said, we're using hawkBit in commercial products and projects, and yeah, there's always stuff we learn in order to get the stability better, performance better, etc., etc. There was one other topic we wanted to do in 2017. Unfortunately, we did not manage to do it. So currently, we are just providing milestones. However, we are very, very close in shipping the first release to Maven Central. I think this won't take that much more time. Unfortunately, we did not manage to do it last year. However, the milestones are quite stable, work very well. So I encourage you to use them. Obviously, you can also start from snapshot, but as you know, there's always a slight risk on that one. So Eclipse release is a big topic, and then somewhere in the future, we want to invest more into integrating with other Eclipse IoT projects, namely especially Hono, in order to make the device integration even more scalable and even more flexible using the Hono ecosystem in order to connect devices to hawkBit. And then there's, of course, a lot of technical stuff we would like to do. There's a lot of upgrades we would like to do. Java 9, of course, is around the corner, or basically is already there. Spring Boot 2, Spring Framework, Vaadin. And that being said, I guess you already get an idea what hawkBit is based on. So it's heavily relying on Spring as a technology framework. Okay. We also worked last year on a lot of features. I guess Michael can't show all of them. Just here, basically a brief overview, small functional features, offline update support. We invested a lot more in rollout management as a capability. Other stuff as well. For instance, you now can define that software custom metadata is shipped to the device as well. This might be useful. For instance, you want to give a device a hint, for instance, how to treat a certain file. So historically, we only ship the files plus necessary installation metadata, like, okay, size of the file, hash sums, stuff like that. Now you can add custom metadata as well. And we even got contributions from other parties. For instance, in DDI API, there is even now the possibility to store state data from the device into hawkBit as part of the update if the device can't store this data locally. So if the device, for instance, had a power shutdown during updating and it needs to figure out where it was and where it started or where the latest state was, that data can also be retrieved from hawkBit. And on DMF, we had quite a few additional capabilities as well. And I think now, yes, I think we can now switch to Michael, going to demo. But maybe that's a good time again to ask for questions. Otherwise, we will go.
I don't see any questions at this point. But yes, like you just say, Kai, for everyone watching, and that's a lot of people actually watching us. Please don't wait till the very end to ask your questions. So yeah, well, Michael, why don't you show us a demo, and we will hopefully collect some questions in the meantime.
Yeah. Also, very happy New Year and welcome to the virtual meetup. 2 sentences to my person, and then we go right through into the demo of the hawkBits, so you can see something.
You're on mute, I think. Okay.
Yeah. Kai muted me. Kai muted me, and not himself. We're sitting in the same room, actually. So my name is Michael Hirsch. I'm working here with Kai Zimmermann at Bosch Software Innovations on a commercial product on the Bosch IoT rollouts in the rollouts team, in the core team, and also one of the committer of the hawkBit core development team. And yeah, I think that's to my person. I'm around in hawkBit. Was here and there on some Eclipse IoT, and we already had a virtual meetup last year with Kai. So I think that's fine for a person. We go right through into the demo. So for that, we should see something now.
Yes.
For that, I'm using actually the Docker image, which already Kai mentioned before. So we are shipping and we are releasing Docker images, and it's very, very easy if you want to get started with hawkBit to just start the Docker images. So you don't need to worry if you're not that close with Maven and the build process. You can build it also from scratch. It's not a big deal, just a Maven install. If you just want to try it out locally, it's very, very easy to just use the Docker images. We also provide even Docker Compose files in the meantime. So what you can see is like we have also RabbitMQ services and a MySQL service for the hawkBit itself. So have third-party services started in the Docker Compose file. And hawkBit also comes with a simulator to simulate some devices. If you don't have devices ready to connect to, you can try it out with the simulator. So this is what we see also in the demo. I've already started it. So we have running 4 Docker images, the simulator, hawkBit's update server as well, the MySQL and the RabbitMQ. If you start hawkBit the first time, you will see actually already logged in. You will actually see the login website. Kai already mentioned hawkBit is not providing a big authentication integration to various authentication providers, so you need to implement something by your own. Maybe wanna do some improvements here. There's an extension for UAuth and UAA servers you can integrate with, but there is something we want to improve here. So there is an admin login for the first time. You can try it out, and this is where you land on the first page. I've already created some demo things, and I will come to this how to build it and how to build these distribution packages for software development. Then I also want to show what started on another board is the simulation device simulator. This also has a REST API. You can simulate devices also via a REST call. This is all described in the documentation in hawkBit. This UI is just really for easier access and easier seeing something here on the UI. So what we want to do, and I want to start slowly with just creating some easy development test devices, and I start just with 5 devices because I want to show that that hawkBit is also very good if you just have a few devices to deploy software. For example, if you have development test devices on your desk and everything, you want to check it out, you can actually just drag and drop software on these test devices singly. So you can just drag and drop software from one target to on the distribution set, and I'll come to it later what the distribution set is all about, and just do a single update. The simulator actually is very, very, I don't want to say dumb, but what it just do is it just accepts the update, downloads the binaries which are behind the updates, and say everything is installed okay. It's nothing installed. There's no system to install software on it, and there's no device to install and then reboot something here. So the simulator just takes the update, download the binaries which are behind the software binaries, and just sends the feedback everything is okay. So this is what we see here with in the first UI what we can do. And the update itself, you can see it in the action history. Kai already mentioned that there is a feedback channel where devices can write feedback, what they're doing. I'm downloading something. I'm finished with the update, and for example, giving some intermediate feedback. So an administrator has a chance what the devices are actually doing. And you can trace all updates in the history for all targets. So we can see the development 0 device has the update successfully installed. I want to tag these development devices for tracking out later, so I can filter them. I can have a tagging mechanism, so I can tag them in, these are my development devices, so I can find them later. This is very, very useful if you want to find test devices, development devices, if you want to tag them by locale, by anything you want to find them back and search for them again. So because updating devices for only 5 or some development devices is kind of boring, and hawkBit is therefore helping you to roll out a lot of a software to a lot of devices. So we want to just generate some more devices here. So let's call in simulated, and we start here with just the 1000. And as you can see, the simulator provides both APIs. Kai already mentioned in the slides. Here I'm using the Device Management Federation API via the AMQP 0.9 protocol, because otherwise I need to wait until the devices are polling for the next time to retrieve the update. But you can simulate both for them, and they will polling again. So we are generating 1,000 devices, and they will also pop up here in the hawkBit server. You can see they're coming in. And now we have in total 1,005 devices. Now I can use my tag to, for example, filter my dev devices are here, and my simulated devices are in the whole view. Now, how to build a software to roll out on simulated devices? First of all, you will start to creating a new software module. I already created one, and I will create another one. So if you want to start, creating a software module, and Kai already showed you a little bit the model behind it, what a software module is. I can create another version of my app, which I just say is a version of 3. And in the version of 3, I can upload software to it, and I have it here. Let's go here. Where's my window go to? My hawkBit window. Don't close it. Let's just take another file. And you can see we uploaded an RAV file, and it's a size of 431 bytes. Now, to build a whole distribution, a software module is only one part of a whole distribution to roll out to your devices. You would need to build a distribution which holds the software module you want to roll out. So let's show a little. I can assign multiple software modules to a rollout, because your software update might not only contain application, it might also contain a runtime. It might also contain operating system to update. So you can build it all in a metadata object model within hawkBit and assign these together, so we can see the modules which are assigned to the distribution set. For this demo, I'm just using one software module. It's just a private. And then we can also see the new simulation in the version 3. So what I could do, I could just drag and drop it to each single device, which is kind of annoying if you have a lot of devices. You don't want to just drag and drop it to your devices. So what you want to do is actually creating a whole campaign rollout management, which Kai mentioned in the slides. So for that, you would need to find your deployment target, to find your devices in filters. So I already created one filter, which just uses, these are all devices. We can check it here. These are all devices. This is just a own query language within hawkBit. You can search for devices. So for that, we would create another development devices. For example, I could use search by the tags, or I can note that they all start with dev. So I find all my development devices. And let's create another filter. For example, all simulated devices. And all simulated devices. So now I can distinguish between my development devices and simulated devices. We are filters. This is very important. If you want to, for example, building your rollout, you would probably have different different categories of devices. You want to start first with the update to try it out, and as Kai mentioned, maybe stop it if there is too many arrows hitting on a rollout. Building a campaign, you can go to the Rollout Management view, and you get a dialog and a wizard which you need to fill out. So let's call just this a first rollout. You will need to select the distribution set you want to roll out to your devices. So let's take our new simulated distribution set in the version 3. And what you now need to do is you need to select a target filter for that. So here I want to use, for example, all devices. I want to roll out the distribution set to all devices. I can write some nice description. And the basic functionality would be you can split it up in a randomly numbered groups, for example, in 3 groups. hawkBit would then calculate, okay, how many targets you are referring to in your filter and split it up evenly in these 3 groups. You can see it, we have 335. If we do it like in 4 groups, you see that the last group is not evenly because we have 1005 targets or devices, and the last group has 1 less. Here you can then configure the thresholds when to start the next group. So how many devices should be successfully installed, and giving the feedback that they are successfully installed in the update to trigger the next group. So you probably don't want to wait until every 100% is fulfilled and then starting next group, because maybe there are some take a little bit longer time. So you want to probably start it in a little bit earlier. And you can also configure the error threshold. This is what Kai mentioned. For example, if there are 10 devices which are sending errors back, the rollout should actually pause, and an administrator has the chance to look into it, what are the errors are, and maybe resume the rollout, continue the rollout, or maybe just stop it at all. And there is another feature which came up also in the slides, which is a little bit advanced group definition. So what this one allows you is actually to define, based on your filters, which target should be in which group. So for that, I can, for example, build a test group for all my development devices. And hawkBit also knows that for these development devices are only 5 within 1005 targets. So you have 1000 unassigned devices which are not within one group. So this is what he already recognizes, and he says you need another group which referring to your leftovers. So we're creating a second group, which is then fulfilled with all the other devices. If I'm using my simulated, these are the 1000 simulated devices. So I will also come up with the 1005 devices. And I can use the triggers based on each group, on each target filter. So for example, for this scenario, I want to use like the development devices should all be totally successful. So I don't want to have any error threshold. They should all go green before I roll it out on my simulated devices. And only if all 5 devices are successful, he should trigger the next rollout group. Oh, yeah. So I can also tell the rollout it should start automatically when he created it, because what hawkBit is doing now, it's calculating which device retrieves which software update, building the groups, and then it will automatically start the rollout when you do the automatically starting button. So let's create the rollout, and it will automatically start. You will see it here. It's already running, starting, and it will assign the software to the devices. So we see the first group, which is actually failing for an error, which should not happen. I know what. Let's take another distribution set. I think my binary file should. Let's do it again. You can see actually now that my devices failed because they are unable to download probably the binary I uploaded before. We can see it in the action history in a second. So I can see the failure. Also good. And this is. Should not happen. This will probably. Yeah, I know why. They won't be able to download the file. Probably. They will all run in an error state. This is also good. Then we also see the error state, how this one is working. So that actually the rollout paused because the error threshold hit and I just resumed the download. So also my simulated devices will lead in an error. So we can check it out, what happened. And I guess he will tell that he cannot download it because I have missed some configuration that my Docker container cannot download on localhost on my system here. This shouldn't happen, but this is my local setup. Not right. We can do something else. Development devices. Add group. This one doesn't have a binary file to download, so the simulator just skipped the download because there's nothing to download because it cannot resolve localhost in my Docker container. This I didn't see coming. So what we now have is we have a second rollout with another distribution set where there's no binary file to download with, so all will go into the installation will be successful because there's nothing to download. So what we can do is we can start a second rollout. And what we can see here in the first group, they all go green, and it will automatically then start the second group. The simulator actually retrieves the event via the AMQP 0.9 push event, so it will react very quickly and return everything is good. And the whole rollout is going to get green. So we have a green rollout here. And we see also in the deployment view that all devices are in a green state. Let's pick, for example, the development 0 device. We can see the last update has been finished successfully. And we can also see in the history that the DMF messages was correct and the simulation is complete. This is what the simulator actually replies to a successful update. Now I want to show one quick feature before we go into the end. This is also a very, very nice feature. If you plug and play new devices, you probably want to update them immediately without like dragging and dropping or defining a campaign. You can actually auto-assign software to devices which matches a specific filter. For example, if a device connects the first time and matches the filter, hawkBit will automatically assign the software to it which matches. So for example, if we here using a simulation distribution in the version 1 for this filter, and this will actually apply to all devices which are matching in this filter. These are all devices. And if you generate or plug and play new devices here, they will actually automatically assign new software to. Maybe we have a quick chance to use soft. Let's generate new devices. Find these. Let's remove the filter. was a little bit too slow, but they already retrieved the new update because the auto assignment already happened. So these are some basic functionalities of hawkBit, and there is much more, as Kai already mentioned. I couldn't show all of them. So the best thing is to check it out, try it out. If you have question, now's I think the best time to ask questions immediately or write it on Jitter, GitHub issue, or on the mailing list. And I think, Benjamin, we're going back to you.
Sure thing, and there are lots of questions for you guys. So in no particular order, let's maybe answer Jörg's question. Is this possible to add device-specific data or metadata, I guess, in hawkBit? For example, can you associate a certificate information to the devices?
Should I answer? In general, you can add metadata. So we have shown these tags. These are basically for business-related metadata, like, for instance, is this a test device, like Mike showed? And we have something called attributes. These are, however, supposed to be provided by the device generally. So that means it's key value based. Basically, the device you can provide as that everything you want to do. However, this has the idea of these attributes is that they are provided by the device, not by UI or management API.
All right. Okay. Another question is, can hawkBit automatically take care of rolling back an update? For example, you want to update 50 devices, and you realize that 10 devices are not updating correctly. So can you properly roll back the whole thing?
No, yes and no. I mean, hawkBit itself has no concept of rollback. We did this. This was actually design decisions in the early days. For security reasons, we decided that from hawkBit perspective, you always do a forward update. However, what you can do is, for instance, you have currently installed version 1 of a software, and then you're installing version 2, and this fails for whatever reason. You can then just say, okay, I'm reinstalling version 1. Usually that means on the device, especially if the device still has version 1 on disk, for instance, and that's what many projects over here are doing, they're just switching back to version 1 because hawkBit told them, okay, please install version 1. And the device knows, okay, version 1 is still there, so I just make a rollback. But hawkBit itself has no concept that you can go back. You always go forward. However, as I said, could be the original distribution set again.
Okay, makes sense. Mr. Crunchy is asking us about the extensions. So I'm not sure if you actually detailed all the extensions that are available today. It might make sense to maybe spend a few minutes on that. And are there more extensions to come?
Michael, will you take over for that one?
Yep. We can actually have a look into the GitHub repo. You can do it also live on your laptop, and I think this is the best way to check it out. So what we did, we figured out there are probably different extension points we are providing hawkBit, which people needs to implement in another way. It depends on your infrastructure and environment you are running hawkBit. Want to maintain it in the main GitHub repository of hawkBit itself. So we started to have this hawkBit extension GitHub repository where we actually also maintaining it, not releasing it in milestones that often. Actually, you can see there is currently no release on the extension yet. We're probably also going to start the release on the extension at one point. But this is also, we are actually happy if somebody want to contribute some extensions for hawkBit, which, for example, there are other implementations on security, authentication. And as you can see here, we already started having different implementations for where to put the binaries to it. So there's a GridFS, MongoDB GridFS implementation where you can store the binaries to. And we actually have also a AWS S3 implementation to store the binaries which you can upload in hawkBit. And there is also, because hawkBit itself doesn't have an authentication mechanism for multi-user, it just have this in-memory user. You can configure the password and the username at startup. There is also a hawkBit extension with integration in OAuth 2 and the UA8 server, which is there, is also maintained. We are not having really integration tests for all extensions. We are trying. It's compiling and it's working. It's not always working. Maybe with the master branch, we are not testing every extension in all combinations. So we are really happy if the community, other people are contributing to it and giving us feedback on that.
Cool.
So from us, there's currently no extension coming in the next couple of weeks, but we are also happy if we have some implementations we would like to put as an hawkBit extension. We actually will also provide it.
Cool. Yeah, makes sense. I mean, for everyone watching, I hope you hear the message here. Feel free to contribute if you're doing anything with or on top of hawkBit. I'm sure the hawkBit team would like to hear from you. There is at least one more question coming for those questions that I just asked Kai and Michael. For the people who asked those questions, if you feel like I didn't give your question justice and I changed maybe the meaning of your question, feel free to use the chat to ask follow-up questions or clarifications. I see at least one more question from Tom. Say I want to develop an embedded agent, hawkBit agent on a constraint device. Where do I start? Is there a code base somewhere that I can work from, or do I need to start from scratch?
Maybe should I take that one? Actually, not that I'm aware that there's something in the community out there. I mean, it's highly probable. What we do have is, maybe I can just quickly go to our GitHub page. So there are two clients, but these are actually, as far as I understand, as at least SW update. There are two clients we have linked from here, but I think both frameworks are not really for embedded. Unfortunately, the only clients I know are proprietary, means, for instance, Bosch internal. I'm not aware that there is an open source project with an embedded client. There's also a client for Android, as far as I know, for Android IoT, right? And those two we have linked here, but none of them is embedded. So maybe they can help a little bit as a reference, but I think there is no starting point that I'm aware of.
Okay, thanks for that. So I think we're done with questions, and timing-wise, well, we're just a few minutes before the end of the hour. So I would like, Roxanne and I would really like to thank you again, Michael and Kai, for doing this webinar. I think this has been really useful and a good follow-up to the previous one we did, like you say, Michael, probably a year ago or something. If there's any additional questions that people have, feel free to use. You can comment on YouTube, or like Kai and Michael said, you can use the project's mailing list or the Gitter chat to talk to the team there. What's next? Well, in 2 weeks' time, we will be live again for a session on Nginx and how you can use Nginx for doing load balancing and basically scale up your MQTT connections. So I'm really looking forward to this one, and it's always good to get guys, you people watching, have any suggestions on topics, please reach out. IoT at eclipse.org, I guess, is the best way to do that. Speaking of which, there is one shameless plug that I would like to make for the Eclipse IoT newsletter. So you probably know that virtual IoT is being run by the Eclipse IoT team, and that is Roxanne and myself. And one thing that we launched in the past few months is a newsletter to which you can subscribe right here on the Eclipse IoT website. There will be a newsletter coming in the next few weeks, actually, with lots of great articles, great resources about IoT architectures, about IoT open source projects. So yeah, this might be something you might want to follow in the future. And with that, I think this is what we had for you guys today. Michael, Kai, have a nice evening. It's getting fairly late here in Europe. For everyone else, have a good day or have a good evening as well. And we'll be in touch. Bye-bye.
Yeah, thank you as well. Thanks for having us.
Bye.
Thank you. Bye-bye.